Okay, hi students, myself B. Ramesh, Assistant Professor in Mechanical Engineering Department, Witsconnect. Welcome to Witsconnect. Okay, as earlier class we have discussed some of the problems. In this class we have discussed again some problems are there. In this problem we have seen this problem, that is express a pressure of 15 bar into kilonewton per meter square, that is 15 bar pressure, it will be converted into kilonewton per meter square. And the next one, express 100 mm water gauge into mm of Hg. Okay, mm of Hg and kilonewton per meter square. Okay, that is 100 mm of water, it will be converted into mm of Hg and kilonewton per meter square. Okay, first we see the 15 bar pressure, it will be converted into kilonewtons per meter square. Okay, 15 bar pressure. Okay, 1 bar pressure is equals to, generally 1 bar pressure is equals to, మన 1 bar pressure ఎంత ఉంటుంది జనరల్ గా, equals to 10 square kilonewton per meter square. Okay, 1 bar pressure equal to 10 square kilonewton per meter square. That's why 15 bar pressure is equals to 15 into 10 square kilonewton per meter square. Okay, this is the 15 bar pressure, it will be converted into kilonewton per meter square. As well as next one, B, that is 100 mm of water gauge, it will be converted into mm of Hg and kilonewton per meter square. Okay, next one. Okay, generally he will be given as gauge pressure. Gauge pressure is equal to, is given as 100 mm of water. 100 mm water. Okay, 100 mm water. Okay, next one, this 100 mm of water, it will be converted into mm of Hg. Okay, Hg, density of Hg is equals to 13.6. Next one, 100 mm of water, it will be converted into, that is 100 by 13.6, it will becomes approximately 7.35 mm of Hg. Okay, first one, 100 mm of water, it will be converted into mm of Hg, and next one, mm of 7.35 mm of Hg, it will be converted into kilonewtons per meter square. Okay, generally we know that 760 mm of Hg equals to 760 mm of Hg equals to 101.325 kilonewton per meter square. Okay, and next one, 7.35 mm of Hg equals to how much kilonewton per meter square? We don't know that value, then that's why we take the x. Okay, then we will apply the crisscross method. Okay, 760 into x, 760 into x equals to 101.325 into 7.35. Okay, x value equals to 101.325 into 7.35 divided by 760. Okay, we know this value cancel అవ్వండి, ఈ వాల్యూని తీసుకుంటే జనరల్ గా ఈ వాల్యూ యొక్క ఆన్సర్ ఎంత వస్తుందంటే it will be obtained as 0.94 kilonewton per meter square. Okay, 0.94 kilonewton per meter square. In this form we will be convert 15 bar pressure into kilonewton per meter square, and 100 mm of water gauge, it will be converted into mm of Hg and kilonewton per meter square. Okay, and next one, again another problem we have discussed, that is next another problem is fourth one, the pressure of the air supplied to a cylinder. Okay, the pressure of air supplied to a cylinder is measured as 80 mm of water. Okay, is measured as 80 mm of water when the barometer is standing at 765 mm of Hg. And the barometer standing at 765 mm of Hg. Okay, next one. What do we find out? Find the absolute pressure. Okay, find the absolute pressure in bars and kilonewton per meter square. Okay, this is our problem. The next what will be given? First we can write given data. Okay, first we have to write given data. Okay, in this one given data what will be given as gauge pressure. Okay, that is gauge pressure. Gauge pressure is what? How much amount of gauge pressure is there? 80 mm of water. Okay, 80 mm of water. It will be converted into mm of Hg. It will be converted into mm of Hg because of the barometer standing at 765 mm of Hg. That's why we find out the absolute pressure. Okay, in this previous problem we converted 100 mm of water into mm of Hg. That in the same case 80 mm of water it will be also converted into mm of Hg. Okay, that will 80 by 13.6 density of Hg, as well as the next we will obtain from this value, that is 5.9 mm of Hg. 5.9 mm of Hg. Okay, next one. I have that next one, absolute pressure. Okay, gauge pressure is obtained in mm of Hg and barometer stands at 765 mm of Hg. That will be atmospheric pressure, is nothing but atmospheric pressure. Okay, absolute pressure. Absolute pressure. Absolute pressure is equals to atmospheric pressure plus atmospheric pressure plus gauge pressure. Gauge pressure. Okay, we know the earlier classes, that is absolute pressure is equals to atmospheric pressure plus gauge pressure in the case of gas. Gauge in the case of vacuum, atmospheric pressure minus vacuum pressure. Okay, how much atmospheric pressure it will be given as 765 mm of Hg. 765 mm of Hg plus gauge pressure is converted into mm of Hg, that is 5.9 mm of Hg. Okay, the sum of both values is 770.9 mm of Hg. 770 mm of 770.9 mm of Hg. That is absolute pressure. Okay, that's absolute pressure. It will be converted into bars and kilonewton per meter square. Okay, bars and kilonewton per meter square. Next one. So generally we know that 760 mm of Hg is equals to 760 mm of Hg equals to 101.325 kilonewton per meter square. 101.325 kilonewton per meter square. As well as we know that that's why 770.9 mm of Hg mm of Hg is equals to how much kilonewton per meter square. Okay, how much kilonewton per meter square. Okay, we know that crisscross method, that is 760 into x equals to 101.325 into 770.9. Okay, 770.9, and y x equals to 101.325 into 770.9 divided by 760. Okay, apply in the calculus. We know that value is 102.8. Okay, generally that obtained 102.8 kilonewton per meter square. 102.8 kilonewton per meter square. It will be converted into bars. That's why 1.028 bars. Okay, divided by 10 square. Okay, divided by 10 square. That's why it will be converted into bars. Okay, that's why 760 mm of Hg equals to 101.325 kilonewton per meter square. In the case that is 102.8 kilonewton per meter square, as well as bars 1.028 bars. Okay, we will convert it in bars and kilonewton per meter square. In this manner we have convert mm of Hg into bars and kilonewton per meter square. One is finding nature and quantity of work if a gas enclosed in a cylinder Okay, if a gas enclosed in a cylinder, that cylinder contains 150 mm diameter and moves the piston in it through 300 mm. Okay, the piston moves in cylinder, that will move piston 300 mm against the pressure of 940 kilonewton per meter square. Okay, what will be given as one cylinder is enclosed. Okay, one cylinder is enclosed. The cylinder is there. Okay, one cylinder is there. This is the cylinder. Okay, its diameter is. Okay, its diameter is 150 mm. Okay, diameter. How much diameter? Diameter. That is small d equals to 150 mm. Okay, 150 mm, and the piston is through the 300 mm against the pressure. Pressure, how much amount of pressure is created inside the cylinder? That will be 940 kilonewton per meter square. That is pressure P equals to 940 kilonewton per meter square. Okay, how much pressure is created? 940 kilonewton per meter square pressure is created on this piston. Okay, the piston moves along the, how much distance it will be moves the piston in it through 300 mm. How much distance it will be moved? That is length, or that is 300 mm. Is nothing but stroke length. That is, stroke is nothing but the piston moves BDC to TDC, that is the stroke length. Okay, మనం దీని గురించి నెక్స్ట్ క్లాసులలో చూసుకుందాం. Stroke length is, how much the stroke length is given as length, piston moving length. Stroke length L is 300 mm. Stroke length is given 300 mm. Next, what is we find out? We find the work. Okay, we find the work. Okay, that's why we find the work. The piston moves one place to another place. That's why the displacement will be changes and applying the force on the piston. That's why we finding the work. Okay, work done formula. Work done, W is equals to P into V2 minus V1. We know this formula as earlier classes. We know that formula, that is earlier classes. In this case, pressure is given, V2, V1 is not given. Okay, then in this part, in this V2 and V1 place, V2 minus V1 is equals to stroke value. Okay, V2, that is length of V2, and the piston moves to the TDC, then that will be value will increases, that will V1. That is stroke length, that is Vs. And stroke length formula is pi by 4 into d square into L. Stroke volume formula is diameter pi by 4 d square into length of the stroke. Okay, in this one diameter is 150 mm and length of stroke is 300 mm. That's why we substitute pi by 4 into d square. D value is 150 whole square into length 300 mm. Okay, we obtain that value is Vs, stroke value is, that is 5.3 into 10 to the power of minus 3 meter cube. Okay, we have obtained in calci, that is 5.3 into 10 to the power of minus 3 meter cube. Okay, next one we will find out work done. Okay, work done, W is equals to P into V2 minus V1. In this case, P into, you know, stroke value, that is Vs. The Vs value is, the P value is 940 kilonewton per meter square into Vs value is 5.3 into 10 to the power of minus 3. In obtain this value in calci, that is 4.98 kilojoules. Units of work done, that is 9.48 kilojoules of work done will be obtained in this cylinder. Okay, this is the one of the problem, and we discussed the another problem is next. Another problem is the pressure in the cylinder. Okay, the pressure in the cylinder varies in following manner. Okay, the pressure in the cylinder varies in following manner, that is P equals to C by V. Okay, P equals to C by V. C is nothing but constant, that is PV equals to constant. Okay, next, in this manner find the work done. Okay, in this manner find the work done if the initial pressure is it is given as initial pressure, that is P1 is given as, and the value changes from 0.02 to 0.08. Okay, if given initial pressure and the value is changes from 0.02 to 0.08. Okay, first we have to write given data. Given data, what will be given? We write as, okay, first what will be given as P equals to C by V. Okay, pressure equals to C by V, as well as the next one it will be given as initial pressure. Okay, initial pressure, that is P1 is equals to 400 kilopascal, that is nothing but 400 kilonewton per meter square, and initial value is given as V1. Initial value V1 is given as 0.02 meter cube. Initial value is given as 0.02 meter cube, and the final value is given as V2 0.08 meter cube. These are values given in the problem. Okay, and next one, what will you find out? Work done. What will you find out? That is work done. You will be find out work done formula. Work done. Okay, work done formula generally we know that W is equals to integration of 1 to 2 W 1 to 2. That is process 1 to 2 is occur in the cylinder. Okay, the process 1 to 2 occur in the cylinder. Then work done 1 to 2, that is integration of 1 to 2 P into dV. Okay, that is integration of 1 to 2 P into dV. In this manner, P is given as C by V. P is given as W 1 to 2. P is given as integration of 1 to 2 C by V into dV. C by V into dV. Okay. In this one, 1 by V is nothing but W 1 to 2. We constant, that is C, takes outside of the integration 1 to 2 1 by V dV. 1 by V dV. Okay, 1 by V dV. The integration of 1 by V is nothing but W 1 to 2 C W 1 to 2 C log E, that is, and V2 by V1. Integration of 1 by V equals to log E V2 by V1. Okay. In the C1, C we will take as PV equals to constant. We will take as PV equals to constant. In this manner, first process 1 to 2, we take as initial state P1 V1 log E V2 by V1. P1 V1 log E V2 by V1. Okay. In this we have substitute all the values in this formula. P1 is given as 400 kilopascal and V1 is given as 0.02, and log E into V2 value is given as 0.08 and V1 value is given as 0.02. Okay, these all values substitute in Calc లో మనం వాల్యూస్ అన్ని టైప్ చేసి మనం ఎంటర్ చేసేటట్లయితే మనకు వర్క్ డన్ W122 ఈజ్ మనకు ఎంత వాల్యూ వస్తుందంటే 11.09 kilojoules of work done will be obtained in this cylinder. Okay, in this cylinder 11.09 kilojoule of work will be obtained. Okay, next another problem is an iron casting of mass 10 kg as an original temperature of 200 degrees centigrade. Okay, original temperature of iron is 200 degrees centigrade. It is closer to 50 degrees centigrade. Okay, it is closer to 50 degrees centigrade. We'll stop. Find the direction and magnitude of heat transfer. Okay, find the direction and magnitude of the heat transfer. What will you find out? Heat transfer will find out generally. Assume specific heat of iron as given as 0.477 kilojoule per kg Kelvin. Okay, we have write the given data. Given data మనకి ఏమి ఇచ్చాడో రాసుకోవాలి. What will be given as given data? As given data is given as initial temperature. Initial temperature is given as T1 is initial temperature is 200 degrees centigrade. Okay, initial temperature is 200 degrees centigrade. It will be converted into kelvins. 200 plus 273, that is 473. Okay, 473 kelvins. As well as next one, final temperature. Final temperature is given as final temperature, that is T2 is given as 50 degrees centigrade. T2 is given as 50 degrees centigrade. It will be converted into kelvins, that is 273 plus 50, 32. Just 273, 303, 323. That is 50 degrees centigrade. 50 plus 273, that is 323 Kelvin. Okay, 323 Kelvin. Next one will be given as specific heat. Okay, specific heat, that is given as C equals to how much given? 0.477 kilojoule per kg Kelvin. Okay, 0.477 kilojoule per kg Kelvin. Okay, next one, find out the heat. Okay, what will be find out? As well as given as mass is also given. Okay, mass M is equals to 10 kg of iron is given. Okay, these are all information are given in this problem. And find out heat transfer. Okay, heat transfer ni manaku find out cheyaladu. Okay, next then we will try and do. We know the heat transfer formula. Heat transfer Q122 is equals to heat transfer Q122 is equals to M into specific heat C into T2 minus T1. This is the formula of heat transfer. We know the already earlier classes. Okay, that is M equals to 10 kg and C equals to 0.477 into T2, as well as in take 200 minus T1 is 50 degrees centigrade. Okay, that is we have common in degrees centigrade. Okay, and Q122 is equals to, in type in calci, we obtain that value of minus 715.5 kilojoules. Minus 715.5 kilojoules of heat is obtained. This is the negative sign. Okay, negative sign indicates the that heat transfer from the system. Okay, negative signs it will indicate the heat transfer from the system to the surroundings. Okay, this is the another problem of heat transfer. Okay, next another problem is 0.2 kg of gas is subjected to change of temperature from 288 kelvins to 458 kelvins. Okay, change of temperature is 288 kelvins to 458 kelvins and at a constant pressure, at a specific heat at a constant pressure. Find the heat transfer and change in internal energy. Find the heat transfer and change in internal energy. Find out as well as given as Cp value is 1.0 kilojoule per kg Kelvin and Cv value is 0.715 kilojoule per kg Kelvin. Okay, first we have write the given data. Okay, given data మనకి ఏమి ఇచ్చాడు? is given as mass. Mass of the gas m equals to 0.2 kg. Mass of the gas m equals to 0.2 kg and initial temperature is given as T1 is equals to 288 kelvins. Okay, initial temperature is given as 288 kelvins and final temperature is given as T2 is given as 458 kelvins. T2 is given as 458 kelvins. Okay, and next at a specified constant pressure, find the heat transfer. Find heat transfer Q and internal energy U, capital U. These are two values that we have find out in these two values. Okay, first one, find out heat transfer. First one, heat transfer. Heat transfer Q equals to, we know the heat transfer formula as earlier classes, m into Cp into T2 minus T1. M into Cp into T2 minus T1. Okay, substitute all the values in this formula. M is 0.2 kg. Specific heat at constant pressure Cp value is 1.0 and T2 value is 458 minus T1 value is 288. T1 value is 288. Okay, next వీటిని మనం క్యాల్సిలో ఇంటర్ చేస్తే మనకి వాల్యూ ఎంత obtained అవుతుందంటే heat transfer, that is 34 approximately 34 kilojoules of heat అనేది మనకు obtain అవుతుంది. Okay, and next one, internal energy. Second one, internal energy. That is capital U is equals to, we know the formula as earlier classes, that is m into Cv into T2 minus T1. Okay, m into Cv into T2 minus T1 and substitute all these values in this formula. M is 0.2 kg and Cv is 0.715 and T2 is already 458 and T1 is 288. T1 is 288 kelvins. Okay, involved in the calci, we get the value of internal energy, change in internal energy, that is U2 minus U1, change in internal energy, that is we obtain 24.28 kilojoules. Okay, approximately we obtain 24.28 kilojoules of internal energy obtained. Okay, దీంట్లో ఇప్పుడు వరకు ఈ ప్రాబ్లమ్స్ అన్ని చూసాము. ఓకే, నెక్స్ట్ క్లాస్ లో మనం we have discussed about the laws of thermodynamics. Those are first law of thermodynamics, second law of thermodynamics, zeroth law of thermodynamics. Okay, వాటి గురించి మనం నెక్స్ట్ క్లాస్ లో చూసుకుందాం.